Students, I have completed 6 online videos pertaining to Heron's formula. In this video lesson, we will be doing revision of Heron's formula, where we will be touching upon some important problems and some key points. Please have a look. Heron's formula. Heron of Alexandria was known as Hero, and he was one who gave the formula for area of a triangle when the height is not known. So Heron has derived the famous formula for area of the triangle in terms of 3 sides. Now, when is this formula used? We use the Heron's formula when it is not very easy to find the height of the triangle, or when the 3 sides of a triangle are given, then we use the Heron's formula. Now, these are some of the key steps to remember while using the Heron's formula. Given a triangle where the 3 sides are known to us, side AB, BC, and AC, what is the first and the foremost thing that you have to mention? The first step will be to name the 3 sides as small a, small b, and the small c. After that, you use the formula for semi-perimeter. The semi-perimeter of any triangle is the sum of 3 sides divided by 2. That is, it is the perimeter of the triangle divided by 2. After having found the semi-perimeter, the next step is you apply the Heron's formula, that is, the area of this given triangle is square root of s, s minus a, s minus b, s minus c. If the triangle is named as PQR, you could write the sides as A, B, and C. I have already mentioned this in the previous video lessons. It is not compulsory to mention that the side opposite to capital A is small a. You could take any one of these sides as A, any one of these sides as B, and any one of them as C. But generally, we take the side opposite to capital A as small a, opposite to B as small b, and opposite to C as small c. Now, after using the Heron's formula, you will substitute the value of the semi-perimeter below S and then write down the difference. That is, you'll subtract the side from the semi-perimeter. And after having doing this, you will get the area of the triangle. So you apply this formula only when the height of the triangle is not known. Now, these are the problems that we have already completed in our previous online videos. This was the first problem from exercise 12.1. This chapter in total has only 2 exercises, 12.1 and 12.2. Children, if you remember, this is the traffic board signal problem wherein the 3 sides of the triangle was given and you had to find out the area. So how did we solve this? We used Heron's formula. The 3 sides were known as A, and A. Value was not given. So by using Heron's formula, we derived the area of the equilateral triangle as root 3 upon 4 sides. After finding out the area of the equilateral triangle by using Heron's formula, we came to the conclusion that this is the area of the triangle, that is root 3 upon 4 side square. Then we calculated the value of A. It was given in the problem that the perimeter of the triangle was 180. Since the perimeter of the triangle was given, we could calculate each and every side of the triangle. And then we substituted that in A. So this is how we had done question number 1 of exercise 12.1. Students, we have already solved this question in our online videos. I'm just taking you to the various questions that we have covered in our previous online videos. Now let's look at another question. This diagram is that of a wall which is on the flyover. And if you remember, this was the advertisement problem where a company has used this much region of the wall to showcase their advertisement. And they had to pay an amount for 3 months. And we had calculated what would be the amount that the company had to shell out for 3 months for displaying their advertisement on the wall, which was on a flyover. So here also we used Heron's formula because the three sides of the triangle was known. Children, this was question number 2 of exercise 12.1. Again, a very important problem. Let us look at another question. Keep the park green and clean. This problem too was done in one of the online videos wherein we found out the area of this colored region by using Heron's formula. Children, this was the third question of exercise 12.1. Heron's formula in an isosceles triangle. So, how would you use Heron's formula in an isosceles triangle? Given an isosceles triangle where the two congruent sides are 12 and 12, and if the perimeter of all the three sides was given, then what would you do? Then you would find out what the base was, and once you knew the base, you would use the formula under root s minus a, s minus b, s minus c. Question number 5 and 6 of exercise 12.1 are based on these type of isosceles triangle. Now, would you use Heron's formula in these triangles? Think about it. I have already mentioned this before. You would use Heron's formula only if it is difficult to find the height of the triangle. Now, in all these triangles, the height is already known, and if the base is given, height is known, and if the base is given, and the height is known, you will not use Heron's formula. Directly here, you would use the formula area of the triangle is half into base into height. So, I want you to remember this, that you need not use Heron's formula in every triangle. When will you use Heron's formula? You use it only if you have to calculate the area of the triangle and if the height of the triangle is not known to you, but the three sides of the triangle is known, only then you will be using Heron's formula. So first and foremost, when you read a question, you should know whether or not to use Heron's formula. I hope this part is clear. I'll cite few examples in the coming slides. Application of Heron's formula in finding areas of quadrilaterals. Quadrilateral PQRS. If you have to find the area of this quadrilateral, you would first find out the area of triangle PQS and then calculate the area of triangle QRS. Add the two areas and then you get the area of the entire quadrilateral. Here, since the height is not mentioned, you would be using only Heron's formula. Now, these are some of the questions that I have done from the textbook. We have finished 12.2 question number 1. Now, look at this quadrilateral. Like I mentioned earlier, would you be using Heron's formula to find the area of both the triangles? In triangle DCB, which is a right angle triangle, You will find out the area not by using Heron's formula, but by using the formula area of the triangle is half into product of the perpendicular sides, because the perpendicular sides DC and BC is known to us. That means the height is known to us, so you will not be using Heron's formula. After having done that, you'll find out the value, or you'll find out the length of BD by using Pythagoras theorem. Once you calculate the length of BD, then you know the three sides BD, AD and AB. You'll find out the area of this triangle by Heron's formula. Add up the two areas and you get the area of the quadrilateral. This is again a similar type of a problem where this is a right angle triangle, and here in this triangle DCB, you will calculate the area by Heron's formula. A trapezium PQRS, and how would you calculate the area of this trapezium? By using the formula half into sum of the parallel sides into height. Now, problems from exercise 12.2 and extra questions. Just let us have a look at the questions that we solved from this exercise. A very popular question, 12.2, question number 8. I hope you remember doing this in one of the video lessons. This is a floral design where there are 16 tiles in total, and you have to find the area of these tiles. So look at this triangle. 28, 9 and 35. The three sides are known. So we calculated the area by using Heron's formula. The same dimensions are given in this tile, which is in blue. So calculate the area of one of the tile in white, and then you multiply it by the number of triangles that you see in this figure. This is again a very important question. Question number 4 from 12.2, where they have mentioned the base of the triangle is resting on this parallelogram. And here we had to calculate the height of this parallelogram. So this is how the diagram looks. You have to draw the diagram in this manner, find out the area of this triangle using Heron's formula. Then how would you calculate the height of this? We don't know the height of this triangle, but you know the area of this triangle by Heron's formula. Area of the triangle is half into base, which is 28, into height. So from that, you can calculate the height. My dear students, what I am doing in this video lesson is just taking you through all these problems that we have done in the previous online videos. So once you look at the diagram, you will know, or it should strike you that we have done that, and these are some of the important questions. Let us look at another problem. The umbrella one, wherein you had to find out the total area used by two different colored pieces of cloth. So this is question number 6 of exercise 12.2. Again, another important question. They have given this also as 50. So we found out the area of one such triangular piece. They asked you to find out the area of 5 triangular pieces which are blue in color and the remaining 5 which are white in color. Another important question, question number 7 from the same very exercise. There were 3 parts to this, part 1, part 2 and part 3, and we had to find out the area of each part. And the diagonal was already given to you. And it was mentioned that this quadrilateral is a square. So what did we do? The two diagonals of this square obviously were equal, because diagonals of a square are equal. Not only that, the diagonals even bisect each other. So we found out this length cm. We found out the area of this entire part in gray by using the formula half into base dB into height cm. So cm was also known, dB was also known to us. Then we found the area of this region in green. Then we found out the same area in this white portion. Both the areas are the same because after all it is a square. And then we calculated this area of region 3 by using Heron's formula because the three sides was known 6, 6 and this was given as 8. So this is also quite an important question. These were some of the extra problems that was given for you all as homework. And I hope you all have solved them in their assignment paper or in your notebook. And there comes the airplane question, the very famous airplane question where Radha makes a paper plane and we had to find out the area of all the 5 regions. So how did we do this? We segregated it into different parts. The nose of the plane, where we calculated this area by using Heron's formula. The body of the plane, which is in the shape of a rectangle, we found out the area by using the formula length into breadth. The base of the plane, that is the tail of the plane, and we use the formula area of one equilateral triangle multiplied by 3. If you remember, we divided this trapezium into 3 equilateral triangles by proving that it is a parallelogram first. I want you to go through those video lessons. And practice it. And then the wings of the plane, wherein this side was given as 6 centimeter. So this was also 6 centimeter, and we found out the area by using the formula area of a right angle triangle is half into base into height, or half into product of the perpendicular sides. So students, we have completed even more problems from 12.2. If you remember the problem based on the cow grazing in a rhombus field, that was also done. So what I have covered in this revision video is a look into all the important questions from exercise 12.1 and 12.2. Now let us quickly solve this. A different question where the perimeter of an equilateral triangle is given as 60 and you have to find the area and height. So here let us assume that each and every side is a centimeter, and since the perimeter is known, we know the formula that it is 3a. We'll calculate the value of a, which you get as 20 centimeter. Now all the 3 sides are 20, but we already know the area of the equilateral triangle, that is root 3 upon 4 side square. Use this formula and substitute the value of s as 20. So 4 into 5 is 20, so you get the answer as 100 root 3. And after doing that, substitute the value of root 3, which is 1.732. You have done this in your earlier video lessons. You've learned how to find the square root by division method. And after having found out the area of the equilateral triangle, use the formula area of the triangle is half base into height. Substitute the values. You know what the base is, but you don't know the height. And when you calculate the height, you get it as 17.32. So dear students, with this, we come to the end of the lesson, Heron's formula. I have touched upon all the important problems which we had done in the earlier online videos. In the next online video, we will quickly look into how to find the square root of a number by division method, and I will be giving you the important questions from this chapter along with few assignment questions. Until then, goodbye and thank you.